If there's one word to describe human nature, it's probably curious. For as long as we've existed, which on the cosmic scale isn't very long, we've been asking the question, why? In our centuries of trying to understand the stars, we've worked out some patterns, some predictions about what we might expect out there, from what we can see. But as we peer deeper into the universe, we've started noticing some unusual phenomena, things that make even the world's top astronomers say, that should not be possible. From unknown celestial objects sending out signals mixed with radiation that shouldn't coexist, to long-dead stars somehow finding the energy to rotate endlessly, to explosions so powerful that they rival the dawn of the universe. But as astronomers are left scratching their heads and wondering if the laws of physics somehow got it wrong, theories from a few thousand years ago propose another explanation. Maybe space isn't actually as silent as we think. Could we be witnessing a kind of cosmic symphony right here in our solar system? And if we are, why are we just seeing it now? Join me as we unravel some of these questions and more, and enter the Codex Legendarium. I'm Shelby Melanson. Imagine a space object so rare that it's described as a needle in a cosmic haystack. That's the story with ASKAP J1832. A quick note about space objects, a lot of them get their names from the telescopes that first spot them and their position in the sky. So in this case, Australia's ASKAP telescope plus its location. What makes this one so special? It's the only known star to send out a 2-minute-long radio wave pulse exactly every 44 minutes. That's unusual on its own, but it got more interesting when we noticed it also sends out synchronized X-rays in the exact same pattern. Now, if you know anything about radiation, you probably know that radio waves and X-rays are basically polar opposites on the electromagnetic spectrum. Radio waves are the lowest frequency, and X-rays are some of the highest. Before ASKAP J1832, they never came from the same cosmic source. But there's even more to it. Astronomers first noticed how weird this thing is in late 2023, when it appeared out of nowhere as an extremely bright star. After that, they went back through earlier telescope data to take a closer look. But what they found blew their minds. It also raised way more questions than it answered. When they looked at that older data, they noticed that there was no trace whatsoever of the object until just before it was first discovered. That means right before we first spotted it, researchers said something dramatic must have happened to it, writing, quote, something powerful enough to suddenly switch the object on. About 6 months later, in February 2024, it suddenly got super bright all at once. And by super bright, I mean so bright that only around 30 other space objects have ever hit that brightness level by sending out radio waves. We're talking 10,000 times brighter than most stars, and we still don't know why or what turned it on in the first place, or even what exactly it is. Think about that. A celestial body just turns on out of the blue and starts sending out beams of super powerful radiation into the universe on a whim. And we don't have any idea why? Was it actually out of the blue? Was there some sort of cosmic trigger that our telescopes can't see? Or is there more to it? Right now, ASKAP J1832 is considered a long-period radio transient. They're just like pulsars, or stars that send out beams of energy from their magnetic poles, which we can see as they rotate. The difference is, pulsars rotate every few seconds, or milliseconds. Energy from LPTs passes us by minutes or even hours apart. It's an extremely new category first coined in 2022, and we only know about 10 of them right now. Even still, this celestial object doesn't perfectly match up with any category of celestial object because of the odd behavior. The leader of the team that discovered it says its mysterious nature could indicate a new type of physics or new models of stellar evolution. Next, let's head over to another one of those 10 LPTs, GPM J183910, or as it maybe should be called, a cosmic lighthouse beacon. But one that, according to physics, shouldn't really exist. Here's why. Just like other pulsars and long-period transients, this star sends constant beams of energy out into space from its magnetic poles. Up close, the beams rotate, like the beacon inside a lighthouse. But from a boat off in the distance, that same light looks like it's flashing every so often. We pick up that star's signal the same way, spotting it whenever the beam happens to point in our direction. It's such a strong, stable pattern that astronomers originally wondered whether these radio signals were actually coming from intelligent life. But that's exactly the consistency that makes it so bizarre. This star has been sending pulses of energy our way every 21 or 22 minutes for 5 minutes at a time, but it's been doing it for 30 years. And that shouldn't be possible. Pulsars and LPTs are actually dead stars, or smaller energy cores left over from massive stars that exploded in supernova. Meaning, over time, they slow down. And once they get below what's called a death line, their magnetic fields become too weak to send out radio waves. But not this one, apparently. The lead researcher on the project straight up says it shouldn't be possible for this object to produce radio waves, but we're seeing them. So where is the star's energy coming from? Why does it still have the strength to send out interstellar signals if it's dead? But if that wasn't weird enough, there's one more LPT that's leaving scientists scratching their heads. This one is affectionately called the zombie star. Let me put it like this. If the last star we talked about is spinning so slowly that it should be gasping for its last breath, yet somehow keeps going, this one is so dead that it might as well be pushing up daisies from beyond the grave, yet it's still breathing. Yeah. Just like other space objects we've been talking about, this one is sending out radio waves too, but at the slowest rate ever. One pulse every 6 hours and 27 minutes. It's a pretty intense jump considering the next slowest is a lively 54 minutes in comparison. Now, there's one other star, a magnetar, with similar rotation speed, 6 hours and 40 minutes. But that one only sends out X-rays, not radio waves. And radio waves are the ones that carry information over massive distances. And just like the other stars, researchers all say the same thing. This one is, quote, one of the weirdest objects in recent times, because we didn't think these things existed, and that these entities are rewriting what we thought we knew about radio emissions. In other words, we don't understand why these things exist. And that's not all. For more than 40 years, astronomers have also been trying to figure out what's behind an unusual and very strong X-ray signal coming from inside the Helix Nebula. You might know it as the God's Eye Nebula, and it's one of my personal favorites. Just like the other stars we've talked about, the Helix Nebula has a dying white dwarf at its heart. And those stars are unusually low energy emitters, aka no X-rays. New theories say the star might actually be a planet eater of sorts, and that the super powerful energy might be coming from the aftermath of tearing that planet apart. But ultimately, we don't know for sure. If high energy beams from stars aren't weird enough for you, what about high energy beams from somewhere else? They're called fast radio bursts, and by definition, they're powerful radio waves that send out more energy than our sun does in a century, except they do it in a millisecond. The issue is, we have no idea whatsoever where they come from. Theories about them are highly contested. Some speculate they come from dying stars or even black holes, but ultimately the true origins of these mysterious beams remain unknown. We've talked about mysterious signals that shouldn't have enough power behind them to exist. But what about on the other end of the spectrum? Energy blasts that are so powerful that the cosmos hasn't witnessed anything like them since the birth of the universe itself. That's what's happening with a brand new class of celestial objects that are blowing minds and space itself. They're called extreme nuclear transients. Let me put them in perspective. Take your average supernova, the explosion of a giant dying star. Most of them release the same amount of energy in 1 year that our sun will send out during its entire 10 billion year lifetime, which we're not even halfway through, by the way. Now put that next to the supernova. Not only is the ENT 10 million times more rare, it's also 100 times more powerful. Yes, an explosion 100 times stronger than a supernova. They happen when a gigantic yet unsuspecting star wanders just a little bit too close to a supermassive black hole. That star, which has to be at least 3 times bigger than our own sun, by the way, starts to get sucked into the black hole and then is ripped apart. The resulting blast would make a nuclear warhead feel like eating Pop Rocks. The top researchers involved say that these blasts are different beasts compared to even the next biggest blasts in space. They added that they stay luminous for years, far surpassing the energy output of even the brightest known supernova explosions. Okay, so that's pretty much an unfathomable amount of energy, with a lot of unexplained origins. But what happens when we take a closer look at those origins? What do we find when we look deep into some of the most far-off places in the cosmos? Before I explain what happened when we did exactly that back in 2006, we need some context. Something as beautiful as it is mind-bending is that looking through space is actually traveling through time. We don't often think about it like this, but when you walk into your backyard on a clear, cloudless night and look up, you actually have a front row seat to billions of years of history. Every twinkle of every star that you see, well, that twinkle might have happened eons ago, literally. And that's just what we see with the naked eye. Let me explain. Imagine finding yourself in one of the darkest places on Earth, under a perfect crystal clear sky. Even then, the furthest thing that you could see is the Andromeda Galaxy, about 2.5 million light years away. It's a distance so inconceivable that when I was trying to come up with reasonable comparisons to explain it, I couldn't find any. But it means the Andromeda that you see when you look up at the night sky is Andromeda from 2.5 million years ago, not accounting for the fact that our universe is actually expanding, which we will talk about another time. Okay, so what happens when we look with a telescope that can see much further into deep space and into the past than our eyes can? That's what happened back in 2006 when NASA launched its ARCADE program. Basically, it was a system of high-end measuring instruments strapped to a high-altitude balloon. They sent it up 21 miles around the middle of the stratosphere, where most weather balloons sit. It was designed to measure the heat from the earliest stars and galaxies in our universe. They were looking for more information about something called the cosmic microwave background, essentially what scientists believe are the energy leftovers from the creation of our universe. And if you thought Andromeda was far, the source of this is 40 billion light years away. That's not far from the edge of the observable universe. But what ARCADE saw, or rather heard, has dumbfounded scientists ever since. Imagine this: the utter endless silence of a void where particles are so sparse, sound waves cannot exist. Suddenly, rocked by a deafening roar. That's exactly what ARCADE found: a radio signal 6 times stronger, or louder, if you will, than their wildest predictions about what could be coming from distant galaxies. It was so loud that it could even drown out other quieter signals from the early universe that ARCADE was actually looking for. The best part? NASA has no idea where the roar comes from, even 20 years later after we first heard it. But if the cosmic roar is really that loud, why can't we hear it? Like we covered before, sound waves that are audible to the human ear can't travel in space. And what if I told you that we didn't even have to travel 40 billion light years into space for these kinds of sounds? A discovery published in 2019 found something similar. Booming celestial sounds exist shockingly close to home. The Earth is surrounded by an electromagnetic shield called the magnetosphere, which protects us from solar and cosmic radiation. We already knew it changes shape in response to incoming space weather from the sun. But the 2019 study found that it actually booms like a drum anytime the sun bombards us with solar wind. Its surface rippling with powerful gigantic waves with every impact. This cosmic drum surrounding us is about 5 times the diameter of our planet, or about 41,000 miles. Or as the study's lead researcher describes it, Earth's magnetic field is a gigantic musical instrument whose symphony affects us greatly through space and weather. As for why we can't hear it, the frequencies we detected between 1.8 and 3.3 millihertz are over 10,000 times too low in pitch to be audible to the human ear. Other studies say Earth's upper atmosphere, called the ionosphere, pulses and syncs up during solar flares in the same way. Here's the thing. Whether you're talking about a space roar that's mind-bogglingly far away in space, or right here in our own planetary neighborhood, ideas about why we can't hear these signals that by nature are vibrational waves and big ones have been around for a very long time. Some people have searched for what might call a deeper explanation. Modern astronomers are far from the first to make the connection between music and celestial bodies. The first mention of it actually goes back about 2,500 years to the philosopher and mathematician Pythagoras. Yes, that one. But this is not your run-of-the-mill a squared plus b squared equals c squared angle solving from geometry class. His idea is called the music of the spheres. Essentially, it's this. Through his observation of the cosmos, he believed that the mathematical distances in space between planets matched up with musical harmonies. And going by that, the force driving the motion of our planets was actually a kind of celestial music. That idea has carried through history for centuries since then. Here's what Roman scholar Cicero wrote 500 years later about the nature of the universe. "What is the sound that fills my ears, so loud and sweet? This," he replied, "is that sound which, divided in intervals, unequal indeed, yet still exactly measured in their fixed proportion, is produced by the impetus and movement of the spheres themselves." He goes on to describe them as symphonies in unvarying harmony. Almost 1,700 years after that, German astronomer and mathematician Johannes Kepler wrote virtually the exact same thing, but he called it the harmony of the world. Side note, if you recognize that name, it's because Kepler was a key figure in the 17th century scientific revolution. He's credited with things like laying the groundwork for the modern scientific method, and with the founding of the 3 laws of planetary motion. The main one being that planets move in ellipses, not perfect circles. You might also know the name from the planet-hunting Kepler Space Telescope, and the celestial bodies that are named after it. Back to harmony of the world, just like Pythagoras, Kepler wrote that the orbits of the planets in our solar system match up with the mathematical ratios or harmonies in music. He described it as the song of the earth. His final theory on the subject expanded that idea even more, saying that each planet has its own singing voice or musical tone based on its distance from the sun. The same idea is a lot more familiar to us than we might realize. Ever hear the musical scale do, re, mi as a kid? Each of those notes actually comes from Latin, and each one describes a different level of the cosmos. It starts and ends with do for dominus, meaning Lord, God, or Master, the beginning and the end of everything. Next is re, the queen of the heavens, or the moon. Mi for microcosms, aka the earth. Fa for fatum, or fates, which is ruled by the planets. So, or sol, for the sun. La for lacte, or milk, aka the Milky Way. Si for cider, meaning stars or constellations. And back to do for God. Another origin theory describes that the musical scale comes from a Latin religious hymn to St. John the Baptist. All of that to say, in Kepler's eyes, the solar system is actually a grand choir, or an orchestra inside a cosmic music hall, with the sun at the conductor's podium. In his words, the sound is a, quote, whistling produced by friction with the heavenly light, and that hearing it provides a very agreeable feeling of bliss afforded him by this music in the imitation of God. There's a really important point to make here that doesn't get talked about very much. Modern science and theology, or the study of religious or spiritual beliefs, tend to be seen as mutually exclusive. You can either agree with one or the other, but not both. But Kepler, Pythagoras, and many, many others are great examples of how the greatest minds of the scientific revolution thought of them as one and the same. They formed their theories based on scientific observation and mathematics, but also in terms of divine harmony and the laws of nature. And at their essence, these two things are not actually at odds. And this more classical way of thinking might actually provide something that we otherwise can't find. Think back to the mysterious radio wave signals, massive energy emissions from stars that should be too tired to sing, celestial explosions stronger than supernova, and the space roar. All of them have something in common. We can't explain and don't understand why they exist in the way that they do. Kepler believed that the song of the planets wasn't something a person hears with the ear, but with the soul. Cicero wrote about the same thing, calling it impossible that such vast movements should sweep on in silence. He suggests that the sounds of the cosmos are so loud that our ears have grown deaf. This sound of the whole universe revolving at the utmost speed is so awful that the ears of men cannot contain it, just as you are unable to look straight at the sun, and your eyesight in its perceptions are overpowered by his rays. He describes the music of the planets as the mystic bond in all things in the universe. As for how we might become able to hear it again, and learned men, by imitating this with stringed instruments and melodies, have opened for themselves the way back to this place, even as other men of noble nature who have followed godlike aims in their life as men. If that's a little too Old English for you, what he's really saying is the same thing that cultures around the world have been saying for thousands of years. Aligning ourselves with the nature of the universe is how we can elevate ourselves, become better versions of ourselves, and depending on what you believe, return to the stars. There's one other interesting idea from Kepler. He believed that at the very beginning of time and space, the creation of the universe, the planets sang in perfect concord. That's a music term for when all notes in a chord agree with each other, meaning it's perfect and doesn't need anything to be added to it to improve it. Put that in physical terms, meaning the planets were perfectly aligned at the beginning of time, but might never be again. Writing, they will never return to the starting point, even after infinite ages. And any astrophotographer or mathematician will tell you he was right. Long story short, each planet in our solar system rotates around the sun at a different rate. Because of that, they very, very rarely line up. And even when they do, it's usually not a perfect alignment. You might have seen science and tech headlines talking about a very rare planetary parade of 3 or 4 planets, the inner planets. That happens once every 40 years or so, but if you want all planets, not including Pluto, to line up, you're looking at once every 396 billion years. But remember, a perfect alignment is even more rare. So if you want all planets to be within 1 degree of each other instead of about 3 degrees off, that timetable goes up to a whopping 13.4 trillion years. In other words, our sun will literally reach the end of its life before that happens, about 3 trillion years from now, with an extra 10 trillion years still left to go. Today, we understand Kepler's whistling as radio waves, and while we're waiting to be able to hear the symphonies of the stars and planets, some creative use of technology is giving a small glimpse into what that could sound like. Just like radio waves, radio data collected by telescopes can be transformed into sound that our ears can process, or almost any other kind of astronomical data. It's a process called sonification. One of the most popular examples is from what's called the singing comet. To create it, the European Space Agency boosted the low-frequency rumbles of the comet's magnetic field to 10,000 times their original strength. The resulting audio has been played more than 6 million times. Take a listen. Other examples include the radiation observed while an ESA spacecraft passed by Saturn's rings, low-frequency vibrations from inside the sun's atmosphere, the sounds of particle trails left behind by shooting stars, or more specifically, the Leonids meteor shower in November 2000. And a screeching roar of Jupiter's electric field, captured by NASA's Juno spacecraft in 2016. A few years ago, NASA even released a Halloween playlist called The Sinister Sounds of the Solar System, spotlighting some of the most creeptacular sounds from space ever. Some more recent ones take it a step further. They pull data from sources like the Chandra X-ray Observatory and James Webb Telescope, and assign musical notes and instruments to data points. From there, the sounds of, or at least musical representation of, black holes are born. If computer-crafted music isn't your jam, some scientists/musicians are getting in on the action too. And to absolutely no one's surprise, science says astronomers working on these celestial melodies and analyzing their data get the joys of both listening to music and improved chances of finding new scientific insights. This is compared to looking at the same data on a chart. Humans first proposed that space is a silent vacuum around 1,000 years ago. Much later, astronauts traveled there and confirmed that their voices fell on deaf ears. But the reality is, space isn't actually silent. We just can't hear it. From X-rays, radio waves, and light radiating through time, to explosive energy blasts booming through the universe, to a powerful roar echoing among the earliest stars. There's no getting around it. There is a lot happening in space that we've never seen before until now, and that goes beyond what we believe should be possible. For now, we're stuck with transforming data into sound that our ears will accept, while we wonder about what's really driving the final frontier. But maybe that's worth thinking about. Did something happen along the way to deafen us to the music of the cosmos? Or is it that our understanding of how to hear it and understand what's out there is actually all wrong? Personally, I think I'm with Cicero and Kepler on this one. Looking up at the stars at night, maybe celestial music isn't meant to be heard with the ear at all, but with the soul. But what do you think is really happening out in space? Why are we suddenly noticing all of these unexplained discoveries now? And just for fun, what do you think the music of the planets would sound like? And if you enjoyed this deep dive into mysteries, myths, culture, and science, drop us a like and subscribe. There's a lot more coming. Thank you.